suppose Vs of t input excitation voltage is u of t for t greater than 0. Okay, unit step function is the excitation. Determine I of t in the circuit using Fourier transform. The circuit is Vs of t input voltage, 1 ohm resistor, 1 Henry inductor. I of t is the current flowing across the 1 Henry inductor. Very simple circuit, single loop circuit. Okay. So Vs of t is u of t. We know the Fourier transform of u of t. What is the answer? Fourier transform of u of t. Last class we solved. Unit step function. Pi delta omega plus 1 over j omega. 1 over j omega plus pi into delta omega. Okay. One resistor is there, that value will not change. Then 1 Henry inductor. So j omega L, the corresponding impedance is just j omega. Okay. Let me redraw the circuit. Vs of omega is 1 over j omega plus pi into delta omega, 1 ohm resistor, the impedance, okay, of the inductor is j omega, the current in the frequency domain I omega. Okay. So this I omega is required. So it's single loop circuit. So you can easily write I omega is Vs omega divided by the total impedance, which is 1 plus j omega. Okay. So Vs omega, let me substitute 1 over j omega plus pi into delta omega divided by 1 plus j omega. This you can simplify. Let me write this in two terms. 1 over j omega into 1 plus j omega, first term. Second term, pi into delta omega divided by 1 plus j omega. Okay. See, this term you can easily do partial fraction. Let me call this term as I1 of omega. We call this as I2 of omega. We know linearity property. Separately you can solve, and if you add you will get the overall result. So let me solve for I1 of omega first. I1 of omega is 1 over j omega into j omega plus 1. You can go for partial fraction. A over j omega plus b over j omega plus 1. solve for A and B. I am just using residue method. A is equal to 1 over j omega plus 1, j omega equal to 0. A, is it 1? Then B. 1 in the numerator, j omega in the denominator, j omega equal to minus 1. So B equal to minus 1. So I1 of omega A, which is 1 over j omega plus minus 1 over j omega plus 1. Apply inverse Fourier transform. I1 of t is, what is 1 over j omega? Any closer result relationship? No, 1 over j omega. Fourier transform table you just see. U of t, is it only 1 over j omega? Other than that, additionally there is pi into delta omega, some other terms are there. What is the Fourier transform of sin t, signum function? Sin t, SGN, signum function, sin t, 2 by j omega. So, can we use that result here? What I am doing, let me multiply the numerator and denominator by 2. So, this 2 by j omega is sin t. Okay? Minus, this is e power minus t u of t. See, remember the results. That's what instead of just displaying the results, I derived everything. U of t, how the results has come. Sin t, how the results has come. Okay. So now let us go for the second term. This I2 of omega. This is I2 of omega. Apply inverse Fourier transform for this. I know inverse Fourier transform equation. Can you tell the equation for inverse Fourier transform? Forward Fourier transform, inverse Fourier transform. Refer it, just refer it. What the? 1 by 2 pi integral minus infinity to plus infinity. Okay, here it is capital I2 of omega e power plus or minus e power j omega t. Is it with respect to dt or d omega? D omega. Okay. See, why I am not using partial fraction means there is only one factor, 1 plus j omega. Okay. So, let me substitute I2 of omega here, 1 over 2 pi, integral minus infinity to plus infinity, pi into delta omega divided by 1 plus j omega into e power j omega t d omega. So, you can cancel this pi. Now, again you need to use the property of unit impulse. You can notice there is delta omega. When this delta omega is valid, the integration is with respect to omega and omega ranges from minus infinity to plus infinity. But what about this delta omega? Only at what is the particular value? 0. See, this is in the frequency domain. I didn't write delta t. This is delta omega. So, omega equal to 0 alone, this is valid. For all the other values, it is 0. So, do not consider other values. Okay. So, at omega equal to 0, this is 1, right? No need of integration, no need of this d omega. When I substitute omega equal to 0, this term becomes 0. E power 0, that is also 1. So, will you get just 1 by 2? Is it right? Is it right? See, now I know the linearity property. Separately, I calculated Fourier transform, inverse Fourier transform for the first term, second term. Let me add, that will give the required I of omega. Okay, not I of omega. In the time domain, it is I of t. So I of t, which is required actually, that is equal to I1 of t plus I2 of t. I1 of t is 1 by 2 sin t minus e power minus t ut. I2 of t, it's 1 by 2. This is current. I'm just using unit amperes. Okay.